So now let's prepare the CubeMX for this project. Well, here we go. So I click on access to my MCU selector. I don't want to do it right now. I don't want to set my connection parameters. Before I have marked my microcontroller, so I click on the star symbol and I find STM32F103C86. I double click on it. My project is being built. Actually, CubeMX is a great thing that has been introduced by ST Microelectronics. It enables the clock of the peripherals, for example, those who are connected to APB2 bus and etc. And you don't need to do it manually. And usually these functions need the knowledge of the address of registers. By this interface, it's a graphical interface. You don't need to know the addresses, and everything is done via a graphical interface. As always, first we need to go to System and RCC. Start by System. Debug. We want to debug it with a serial wire. Serial wire relates to ST-Link. And go to RCC. We need to enable high speed clock. So we enable it. Crystal ceramic resonator. Yep, we're done. So, as we said before, our input in this project is B11. So we need to find B11 because push button is connected to this pin. Here is pin B11. So we click on it and we need to find GPIO input because the push button is connected to this. So it is our input. And pins B12 through pin B14 are our outputs. So we set them as GPIO output. Yeah. And about analog, which is related to ADC, timers, connectivity, computing, and etc., we don't need to do anything. So let's check the clock configuration. I usually use the maximum frequency. The calculation of the frequency is important when you are enabling ADC, which we will consider it in the upcoming videos. No solution found using the current selected sources. Do you want to use other sources? It needs to change, for example, this HSI and HSEN, etc. multiplied by 2 PLL. It needs to enable them, and it is asking for a permission. So click on OK. Yep. Project manager. A name for your project. I like to call it GPIO input and output or IO. Project location, you could choose wherever you want, but in my case, I would like to create a new folder here and call it GPIO IO, and I want to save it there. The tool chain that I'm going to use would be MDKR or Kale, and the minimum version is okay. My Kale version is upper than 5.32. Code generator, copy only the necessary library files. And tools you don't need to do here, but before generating the code, I want to explain pull up and pull down. So we come back to pinout and configuration, click on system view and go to GPIO. input is important for us. As we said, PB11 is our input, so we click on it. So the configuration opens here for us. The GPIO mode is input, but it is no pull up and no pull down. What do we mean by it? Let me explain something to you. Let's say when the push button is pressed, it is connected to pin 3.3 volts and its value is high. But what when it is not connected or to other volts, the button is not pressed? What is it? It is high or it is low. Of course, it is not high because it is not connected to 3.3 volts anymore. But is it down? Of course not. It was low. Its value was low if it was connected to ground. So what is its value? Technically, in this situation is called high Z, and it is undesirable. Here, the concepts of pull up and pull down take place. But what do we mean by saying pull up and pull down? Let's review these concepts in a second. I want to explain the concepts of pull up and pull down resistors and generally pull up and pull down with this picture. It helps us so much. So let's start by pull up. This is our MCU, and let's imagine this pin is our input, and we want to write a program that does a specific function for us whenever its value was low or it was connected to GND. So whenever it was not connected to GND, we don't want to do something, so it must be connected to high value, whatever it is, 5 or 3.3 volts. It is important to be high. But we need a resistor. This resistor value is usually so high, in range of 10 kilo ohms. Something like that would be a good option. So when the switch is disconnected, it is connected to VCC. However, the path to VCC is so hot because of the high resistance, but it is connected to high value, and it is not disconnected from everywhere and gets noise. Or, as I said, the high Z situation does not happen. When this happens, it accepts the noises. So it could do unforeseeable behavior, which is undesirable. But whenever the switch is connected, here is no resistance to the ground theoretically, or practically it is so low compared to this big resistance, so all the current goes here, so it is connected to ground. This is the definition of pull up. Now let's go to pull down resistor definition. This is pretty much close to the definition of pull up resistor. This is our MCU, this is our input. We want to write a program that whenever the input value was high, the MCU does something for us. But when we want it not to do anything, it must be connected to ground via a big resistor in the range of 10 kilo ohms, for example. But as soon as the switch is closed, all currents goes here and not here. All the currents flows from VCC to the pin, and its value would be high, and the MCU would do our desirable function. It was all I wanted to tell you about pull up and pull down. And finally, we click on generate code, and we press open project. Yeah, our project is built via CubeMX code generator.